Hello, welcome to In 5 Minutes. Today we'll be starting with Laplace Transform. Now, what is exactly meaning of Laplace Transform? We have a function f of t. This function is nothing but an independent variable of t. I can say function of independent variable t. We are going to transform this function to phi of s. Now that is nothing but function of complex variable. So complex means where you get a real term as well as imaginary term. So I say complex variable. So when I have said complex variable, then what is this exactly complex variable is? So complex variable s. So here t is going to transform to s, where s is said to be sigma plus j omega. I'll say what is sigma and what is j omega. Understand, students? You have a y-axis and x-axis. So x-axis is said to be a real axis. So with respect to s, it is said to be sigma axis, and y-axis is said to be j omega axis. So this plane is said to be s plane. So we can say function of t, whichever points of t are there, they are going to map to s plane. So we can define a definition, that is Laplace integral over 0 to infinity, that is from 0 to infinity. Understand, students, Laplace can be defined for minus infinity to infinity also. When you define it from minus infinity to infinity, we say that is as bilateral Laplace transform, and when you define from 0 to infinity, you say as unilateral Laplace transform. So Laplace integral over 0 to infinity defined as Laplace of f of t, that is equal to 0 to infinity e raised to minus st f of t dt. So this is nothing but which we have got, that is definition of Laplace transform, which we need to remember always. So we need to find there are different functions. Whichever functions will be there, we will be substituting here and we will be finding Laplace of that. So now I'll be going with first standard formulas of Laplace transform. So we know, students, we have different functions. Trigonometric functions, exponential function is there, then algebraic function is there. I'll be writing all the standard formulas of Laplace transform, starting with first Laplace of sin 80, that is a upon s square plus a square. Second, Laplace of cos 80, that is s upon s square plus a square. So this is trigonometric. In the same way, I write this third one, Laplace of hyperbolic function, that is sine hyperbolic 80, that comes a upon s square minus a square. Fourth, Laplace of cos hyperbolic 80, that is s upon s square minus a square. See, you can easily remember difference between hyperbolic function and a trigonometric function. Only in denominator you have a minus sign. So fifth one is Laplace of e raised to 80. So that is my exponential. Understand very well, if it is e raised to plus or it can be minus. Now what changes exactly in formula? It comes 1 upon s. See, if it is plus 80, you need to write minus. If it is minus 80, you need to write plus. That's the change. So my next formula is Laplace of t raised to n, that is algebraic. You have two formulas here. One is n factorial upon s raised to n plus 1. The second is gamma of n plus 1 divided by s raised to n plus 1. Now you will be thinking when to use factorial and when to use gamma. See, if your n is integer, you need to use this, and if your n is a rational number, you need to use gamma formula. The last one, that is constant. If you need to find Laplace of a constant, that is say k, then it is nothing but k by s. I do mention here k is nothing but a constant. Now, out of the 7 formulas, what I do, I just prove sin 80 formula by my standard definition.